Hello, thank you for attending the GSE UK Conference 2021. This is session 2BC, which is zVM Centralized Service Management, and I'll now hand over to presenter Richard Lewis. Any questions, please place in the chat, and I'll relay those to Richard as we go along. Over to you,
Thank
Richard.
you, David. Thank you very much, David. As David said, my name is Richard Lewis, and I work at the IBM Washington Systems Center and have been supporting zVM and Linux on IBM Z for my entire career at the Systems Center. So what I'd like to discuss with you this afternoon is the zVM Centralized Service Management capability, and this is new function that was added to zVM 7.2. In fact, it was probably the most prominent of the new function that was included in zVM 7.2. So I'd like to review very briefly the current VM service process without CSM, then give a very brief overview of CSM, look at what is delivered with this new function in detail, and then hopefully put all of that together with a sample scenario of how you would use CSM. And then if we have enough time at the end, look briefly at some new function projects that are related to CSM, and those are sponsor user opportunities. So let's review the current service process. And for a standalone zVM system, the most notable aspect of service is that you have to execute the full service process on each non-SSI zVM system. So if you have 1 or 2 systems, that's not too bad. If you have 30 LPARs, then it becomes kind of tedious. And what I mean by executing the full service process, you have to transport a service envelope to each system. You've got to run the service command on each system. You would test each system separately. You have to run put to prod on each system independently. And the service inventory is maintained separately on each system. So sometimes it becomes fairly hard to keep track of what service is actually on a particular non-SSI zVM system. So those are problems that as you scale your VM environment horizontally, problems that need to be addressed. Now, if you're running an SSI cluster, the service environment is better. And that's because in an SSI cluster, you have shared DASD, you have virtual machines that are single configuration virtual machines, so they carry their context with them no matter which member you're logged on to. So it's possible in an SSI cluster to simply install the service once. So you would transport the service envelope to one member in the cluster. You'd run the service exec on that member in the cluster, and you could choose then to do testing there and eventually put the service from that member into production, but you wouldn't have to. Perhaps another member in the cluster has an available downtime that this particular member doesn't. So you could go to that member and simply put the service into production on that particular member, recycle it, and work through the members in your cluster. And so in terms of the VM says inventory, in an SSI environment, there is a cluster-wide portion of that inventory and then a member-specific part. So it's possible to keep track of service for the cluster as well as related to each individual member a bit easier than what you'd find in a non-SSI environment. So with that in mind, if we take a look from an overview point of view at CSM, The objectives for introducing CSM are to try to extend some of the efficiency that you find in an SSI service environment to non-SSI zVM systems. And so specifically what that means is to try to eliminate the need to run through the full service process on every non-SSI system. So with CSM, you'll have two categories of VM systems. One system will be designated as the principal system, and that's where all of the service process is executed, if you will. And then you'll have lots of managed systems. And so a service level that's created on the principal system will simply be transported to a managed system, installed there. You can test it separately on that managed system and then ultimately put it into production. So you'll have one VM system where you'll transport your service envelope, you'll run the service exec on that envelope to create what's known as a service level on within your principal system, and then you'll transport that service to managed systems. So it definitely cuts down on the tediousness of managing a large number of LPARs from a service process. It centralizes a service inventory, if you will, on one system. So it's possible to just be on that one system and find out what PTF has been installed on a particular system, what service level, and so forth. And so hopefully it makes the service process a lot easier in a non-SSI environment. Now, it's been designed for installations with a large number of systems. So if I'm a small shop and I have 2 VM LPARs, it probably doesn't make a lot of sense to implement CSM. It'd be faster to just install service on each of those LPARs. But as I said, if I'm a customer with 30 or so, or even 20 LPARs, you'll find benefit from implementing CSM. One thing I want to call your attention to on this slide is a PTF UM35726, the APARS VM 66428. This is crucial service that it needs to be installed on the VM systems that are going to be participating in CSM before you use CSM. This PTF did not make the GA cutoff for 7.2, so it was not on the GA RSU. It happens to be on the 2101 RSU for 7.2 at this point in time. But you need to make sure that this service is installed on the principal system and any managed systems before you start using CSM. So a little bit about the components that make up CSM and some limits that are built in at this point in time. As I mentioned, there's this concept of a principal system, and it can be any non-SSI zVM system that you choose to designate as the principal system. On the principal system, you'll use the shared file system to manage service levels and the definitions and status of managed systems. And that's where you're going to execute the service process, for example, running the service exec that would probably be familiar to you today. And really everything related to CSM is going to be executed on the principal system. And then the principal system will push a set of service out to the managed systems. The principal system cannot be a member of an SSI cluster. The managed systems cannot be members of an SSI cluster at this point in time either. And the current maximum in terms of managed systems is 54. So that limit will no doubt change. And I know that VM development is analyzing whether to bring an SSI environment into CSM. So you might see those restrictions being lifted in the future. So I've used this term service level, and that's what CSM manages along with the target systems. And so what is a service level? It's basically any service deliverable from IBM. So it can be an RSU, it could be corrective service, it could be emergency service, it could be a local modification that you're making or a local modification that is relief. So anything basically that uses the service process to install would be would comprise a service level. A service level is always built on some base. And so when you initialize CSM, you're going to have the base components from VM installed in the shared file system. And then you're going to use that base to build initial service levels. Once those are built, you could choose to base a new service level on a previous one. But there's always this concept of a base that is the starting point for a service level. A service level also includes whether or not the managed VM system is running an external security manager or not. Since an ESM represents modifications to the CP component of VM, where the external security manager substitutes its own code for stub modules that are included in the CP nucleus, since that requires a rebuild of the nucleus, which is a service process. Whether or not the managed system has an ESM or not is relevant for a service level. So if you have a mixture of VM systems, one might have RACF, let's say, and another does not, and you wanted to put the same level of service on both of those, from the CSM point of view, you'd have to build two different service levels. One service level would have ESM code initialized in it, as well as the actual service installed. The other service level would not have an ESM initialized in it and would have the service installed. The shared file system is used on the principal system to maintain basically everything about CSM. And then the principal system will transport a service level to managed systems using a dedicated special purpose FTP server that's running on the managed systems. And that's also going to be used for the principal system to actually send commands to the managed system to get the managed system to do service-related functions. So with that overview, let's take a look then at some more detail in CSM. So some of the pieces and parts, if you will. You're going to notice that you'll have some new virtual machines, and a number of these virtual machine definitions were actually already included in 7.1. People were probably wondering what they were, but quickly forgot. With 7.2, these virtual machines actually become usable with CSM being delivered. So one virtual machine, main CSM, is going to be used only on your principal system, and you're going to do all the CSM related work from that virtual machine. Now, since all of the information that CSM is working with, service levels, system information, is stored in the shared file system, the main CSM virtual machine needs to be a file pool administrator within the VMP SFS file pool. That's the file pool CSM is going to use. Because it's going to be creating new file spaces, it's going to be constantly creating new directories within that file pool. Another virtual machine named CSM work is defined in the directory. You don't ever really log on to it. It simply exists as the credentials that will be used to log into the special purpose FTP server on a managed system. So that special purpose FTP server can only be used by CSM work by default. Now you could configure it to recognize and use a different user ID if you want, but by default, CSM work is the only user ID that can log in to that remote FTP server. You still will have your traditional maintenance user ID, so maint 720 in this case, and you would use maint 720 on the principal system to do service installation on that system unless you choose to have CSM actually manage the principal system as well, which is an option but not a requirement. And then maint 720 is going to be used by CSM on the managed system in disconnected mode to actually do all the service related activity on that managed system. CSM serve is the virtual machine that will run the dedicated FTP server on the managed system. And only, again, CSM work is allowed to log into it. Now, within the VMP SFS file pool, maint CSM will have a file space. When you initialize CSM, a new file space will be created, CSM 720, since that's the only release right now that CSM works with. And so that is the file space ID that's going to not only include all the directories that represent the base of 720, but all of the directories that are created to represent every new service level that you installed. So they'll all exist underneath the CSM 720 file space ID. There are also a couple of new VM-Says data tables. So CSM sysstat is the table that defines all of the managed systems, and it has all of the information CSM needs to be able to contact the managed system and maintain service level details about that managed system. And then there's the CSM SVC or service stat table, and that defines a service level that you create in CSM, and it points then to the set of directories within VMP SFS that represent that particular service level. As these are regular VM-Says tables, they're all maintained and manipulated by the VMFSIM command. Now, I mentioned that you start when you initialize CSM, you start with a base, and the base content exists when you install zVM 720 on maint 720's 5 Baker Charlie mini disk. So a lot of customers notice when they're installing maint 720 that the install process seems to pause for a period of time when it's loading the 5 Baker Charlie mini disk. And that's because it's a big mini disk. It's 3,000 cylinders in size. And the content of that mini disk is simply a single file called CSM 720 as the file name and unload as the file type. And it is an SFS file pool unload of all the base directory, SFS directories for all of the components of VM. So those are the base components and the optional features of VM, everything that would be serviced by an RSU. Now, as 720 is installed, the VMP SFS file pool does not contain enough space to hold that base. And that's because there's no need taking up a lot of space if you're not going to use CSM. So one of the things you have to do very early on before you even initialize CSM is you need to make sure that your VMP SFS file pool has enough, at least a minimum amount of storage in storage group 2 to hold the base directory. You'll need much more than that, so it makes sense to when you're adding space, add 3 at least mod 9s to storage group 2. That's enough to cover the base and several service levels that you might create. Now, in terms of service level content, again, that's a set of directories under the CSM 720 file space. And the directories that are created are really the directories that would correspond to the VM says delta apply and build strings of mini disks that are defined in PPF files. So everything that VM says would set up on mini disks, for example, to do service, a corresponding directory is created within a CSM service level for that content. And so you have the full delta apply and build strings. Now, in addition, the directories for a service level will also keep all of the service inventory files that correspond to that particular service level. So this would be, for example, the receive status, build status table, the apply status table, and all of the version vector table entries and things like that. When you're ready to send a service level to a managed system, the content of those directories that are representative of the service level they're packaged into component-based servlink files along with a manifest file, and those files are all transported to the managed systems to be loaded on that managed system. So CSM does lots of manipulation of the VM-SESI profile and overrides to the new CSM PPF. Every time you create a service level, a unique VM-SESI profile is created for that service level and stored in the top level directory for the service level, along with an override file for CSM PPF, so that when you run the standard SES tools, all of the work from, say, running the service exec goes to the right set of SFS directories that represent that service level. Now, here's an example of what how a system, a managed system, would be represented within the shared file system. So again, main CSM is the file space ID for the directory structure for managed systems. And then each managed system has a high-level qualifier under main CSM. So if I added a system called system_1 as a managed system, there would be a high-level qualifier system1 under main CSM, and then a bunch of other directories that house information and log files from that particular managed system. As far as the managed systems are concerned, each of those systems just maintains its regular native VM-SESI environment. So, it's standard 5.1 dog and 4.1 dog, as well as all the VM-SESI either SFS directories or mini disks, depending on how that system was installed. And the same would be true on the principal system. If you're not having CSM manage the service on the principal system, then that system has its own service environment that is managed from the main 720 virtual machine and really has nothing to do with CSM. Now, when CSM is installing, having you install service into a service level, you're going to run the regular service exec under the control of a CSM tool, and I'll give you the name of that in I think it's the next slide. And a problem exists when you're loading service using the service exec in that if your target is entirely a set of SFS directories, you have a real difficulty if, for example, you have service that affects the CMS nucleus, for example. The CMS nucleus exists on a mini disk in a set of cylinders that are recomped. In other words, they're hidden cylinders from the rest of the CMS file system on, for example, the 190 mini disk. And when you run the service exec, the new service is loaded and service rebuilds the CMS nucleus, and it writes the new nucleus out to the nucleus cylinders on the alternate nucleus build disk. So that would be the 490 mini disk owned by Mate 720. And you could test that new CMS nucleus when you run put to prod. Then the put to prod process copies those cylinders over to the runtime CMS nucleus mini disk, the Mate 190. So what happens with CSM? Well, to allow this all to work, enhancements were made to the service exec, and a new tool named CSM package load exec was created to run on managed systems. So when you run the service exec to install service into a service level set of directories, the service exec, when it gets to the point of building the CMS nucleus, is going to use the build nuke virtual machine to actually build that nucleus on a temporary mini disk. And then it's going to DDR those cylinders to a file that is in the CSM test build SFS directory for that particular service level. So those cylinders now, or those cylinders exist as a file in that SFS directory. When you send that service level to a managed system, on the other end, CMS package load will process those servlink files, and it's then going to reverse that process. So when it gets to the point of having to put a nucleus on the 490 mini disk, what it's going to do is DDR the nucleus file that exists in the SFS directory to the alternate build mini disk, the 490, and then that installs that update to the CMS nucleus. You can then test on that managed system by linking to that mini disk. When you run put to prod on the managed system, it functions without change. It just copies from the 490 to the 190. All right, so the one command that really runs everything with CMS is serve manager. It is a new command. And so serve manager allows you to do everything that needs to be done within CSM. It will allow you to initialize the CSM environment. That's the initialize subcommand of serve manager. It allows you to do everything you need to do with a system under the serve manager system command. So add, delete, modify, put service into production, and so forth. It allows you to do everything with a service level using serve manager serve level. And it also allows you to take a managed system out of the CSM process temporarily. So that's the serve manager managed command. That's the only invocation of serve manager you would ever run on a managed system. And this allows you to handle a sort of a situation that probably wouldn't come up very frequently, but perhaps one of the best examples is if you choose to enable a new product or feature, I should say, on that managed system. So if I've never enabled Performance Toolkit on my managed system, and now I've purchased a license and I want to do that, I have to be able to run the service exec on that managed system to enable Performance Toolkit. And if that target system is a managed system, that the process of adding that system as a managed system turns a flag on that tells the service exec you can't run on this particular system. So there'd be no way to enable a performance toolkit. So to get around that, you can log on to main 720 on that target system and run serve manager managed off, and that will flip the flag to the off position. Service can run, so you could do service perf svm sfs enable and enable performance toolkit, and then run serve manager managed on again, and now you flip the flag back to being on. So that's the only invocation of serve manager that you'd really ever run on a managed system. There's the capability to build a main CSM names file, and that allows you to provide nicknames to reference multiple managed systems. And the serve manager command for some of the query options allows you to supply a nickname. So if I want to query the service level of all of my managed systems that are ESM based, well, I could create a nickname for those set of system names and just do a serve manager query against that nickname. There are updates to existing commands and execs with CSM. One notable one is that the profile exec for main 720 is updated now to include logic that will determine if main 720 is logged on in a disconnected state. And if it is, then out of the profile exec, it will invoke this new code CSM agent, which basically sits there waiting for communication to it from the CSM serve virtual machine, that dedicated FTP server. So the only reason I bring this up is that if you're used to perhaps modifying main 710 or other maintenance virtual machine profile execs to include some of your own logic, you probably want to avoid doing that with main 720's profile exec. It's possible to create another exec where you can put your logic and then uncomment the portion in main 720's profile exec that calls that other exec, and that's the best way to put your logic in, because you don't want to run the risk of introducing an error into main 720's profile exec that causes it to not run all the way through to invoke CSM agent. If that happened, then you'd break your CSM environment. The service exec was updated to accept 16-character service level values, so you can create long names for service levels. The system service update facility table now has this new CSM managed tag that's interrogated by the service exec. So if you're running service on a particular system, it's going to look at the CSM managed tag to see if it's proper to run service exec or not. If CSM managed has a value of yes, then the service functions can only be run under the control of CSM on that system. Okay, so with that as a background, let's run through a sample sample scenario here to hopefully put all these pieces together for you. So as I said, the first thing you're going to want to do is set up your principal system. And so you'll need to make sure that VMP SFS has enough space to at least be able to initialize the CSM environment. You'll want to make sure that you have a service already installed on that system that includes that critical PTF for the CSM environment. And once you've got the prerequisites done, you're going to then want to enroll main CSM as an admin in the VMP-SFS file pool. And then you'll run the serve manager command from main CSM Serve Manager initialize 720. 720 is the only level that works with CSM at this point in time. That will, of course, change once 7.3 becomes generally available. So the initialize command will do a bunch of work, and the largest amount of work is to actually do a file pool reload of that unload file and populate the CSM 720.base file space with all the directories that represent the components and features of VM. It'll create the service level table and initialize that table with the base information, and then it's going to generate a bunch of bitmap and VVT local summary files for each of the components that are part of the base. Now, it's important to remember that when I say base, it is really the base of VM. It does not include the content of the GA RSU that comes with your order. So these are really the base level of VM components. So one thing you're going to have to do immediately is actually create a service level that includes the GA RSU and has as a base, this base, that at least gets a service level into the system that would represent the service level of any installed 720 system. One other piece of customization you want to do on main CSM is to copy the FTP sample data file from TCP mains 592 to the main CSM, CSM 720 directory, rename it to be FTP data, and then modify the data connect time value in that file to be the maximum value of 720 seconds. Some of the commands that are run from CSM communicating with that target FTP server are long running, and you don't want those FTP commands to time out. So you're going to for sure want to create a service level before you define any new systems to be managed by CSM. And you create a new service level with the serve manager serve level command. So here's an example of doing that. I'm going to do serve manager serve level add. 720 is the release level. My name for my service level is this long name VM 010102 underscore build one. So that's just the name of the service level. It will result in a directory qualifier being added under CSM 720, and all of the directories for this service level will be under that qualifier. I'm basing this service level on the keyword base. So this is the base set of directories that were just created with the initialize command. It's a non-ESM service level. And then following the description keyword, I can just type any string I want, a comment that indicates some relevant information about this service level. In my case, it's the initial RSU install. So running that command takes and it copies the 130 SFS directories that were created under the base qualifier of CSM 720, copies them over under the VM 010102 underscore BLD1 qualifier. So now I have a set of directories associated with this name. Now, obviously, I need to put some service on the content of those directories, and I do that using the regular service exec under the control of serve manager. So serve manager, serve level, service. The next operand is the release, so it's a 720 release. The name of the service level that this service is being installed into. And then the last two arguments are what you would normally include with the service exec. So service all the name of the envelope file is RSU0801. And I have to have access to that envelope file from maint CSM, which is where I'm running this command. So this really just runs the standard service exec on that envelope, installing all of the serviced components and anything that needs to be rebuilt for the service into the SFS directories that are represented under VM 010102 build 1. So that actually adds service there. Now, if I was installing the GARSU, I also want to make sure that I include the PTF for VM 66428 in this service level. So that would be a second invocation of service under this service level, pointing to the envelope file that actually has the service for that PTF. Now, once I've done that, I'm able now to potentially add a managed system to CSM. Now, before I add the managed system, I need to do some configuration work on that managed system. So I need to configure the CSM serve virtual machine as a TCP/IP FTP server. So this means modifications to the profile TCP/IP, the DTC parms file to add a new server, CSM serve as a type FTP server. So that's the most critical work that I need to do. I also need to enroll CSM serve and CSM work as administrators in VMPSFS, because those serve-link files will simply be stored via the FTP command temporarily in VMP SFS until service can actually run and put the content on the appropriate maint 720 either SFS directories or mini disks. So there is SFS space that gets consumed on the managed system, but nothing near in terms of size that you would have on the principal system. The other requirement is I need to make sure that I have a service level defined in CSM that's either equivalent to the current service level on this managed system or a superset of the service. So that is a requirement, and that's why I had to make sure I had that GARSU service level there, assuming that this managed system is just at the GARSU level. So the way to add a system is with the serve manager system command. So serve manager system add 720 service level. The name I want CSM to know this system by, and so I'm calling it VM01. The initial service level that this system is at, so it's at my VM 010102 build 1 service level. It's a non-ESM system. Following the host name keyword, I can either put the fully qualified name of the system, or I could put the IP address of the system. Communication type is FTP, and port 4535, and I'm not running TLS on this port, so no secure. So I don't necessarily have to put that COM type set of arguments in. The defaults are FTP, port 4535, no secure. So if I'm doing anything other than the defaults, then I would have to include those arguments as well. So this will cause the principal system to communicate with the managed system. And so that FTP server needs to be there. On the managed system, it's going to actually xautolog maint 720 if it's not already logged on. It's going to verify that the service level of this system matches the service level VM 010102 build 1. And if everything works out, then it will cause the managed system to run that serve manager managed on command to flip the bit in the VM sysuf table and it will then create information in the directory tree under main CSM for VM01. Now, once I have a managed system, if I have some new service to install, the next step I would typically do is define a service level. And so again, that's done with the serve manager serve level add command. So I give the service level a name. In this case, I'm going to base this service level on my GARSU service level. So I'm basing it on that VM 010102 build 1. Again, it's a non-ESM system and service level. So this is the August RSU install. So this will create under CSM 720 this new set of directories under VM 010802 build 2. It'll copy the 130 directories from the based on service level over to this new high level qualifier. So now I'm ready to install the service. So assuming I have access to the service envelope, I'd run serve manager serve level service, again, 720, reference the service level name, and I'm going to install all the service from the envelope RSU 0802. So this updates all of the pieces and parts that would be affected by this RSU install in the set of directories under that high level qualifier. Now, once I've got that service level created, it's created in what's known as a test build state. And this allows me to add additional service to that service level if I want to. For example, perhaps I forgot to get the bucket set of service for this RSU and I go order that. I want to make sure that those PTFs are on. So I re-invoke the service command again for this service level to put even more service into that service level. So as long as it's in a test build state or an unlock state, I can do that. When I'm ready to send the service to a target system, I will use the serve level package command. And so that's, you see this invocation there. I simply reference the service level name. It's of course a 720 service level. That causes the set of serve link files to be built along with a manifest to be sent to a target system. It doesn't send the service level, it just builds those serve link files. To actually send it to the target system, I will use another invocation of serve manager. Now, if I wanted to force this service level to not be updated or to not allow me to add any more service to it, I could manually set a lock on the service level, but you probably aren't going to do that very often. So to actually send the service level to the target system, I'll use serve manager serve level send. And again, it's a 720 service level, the name of the service level, and then the target system, VM01. Serve manager knows what the IP address or fully qualified name of VM01 is, because that information is in the system level information, system level table maintained by CSM. So this will cause an FTP session with VM01, and the FTP session will result in the CSM agent program being invoked within mate 720. All the serve link files will be transported to VM01. Once the serve link files have been received, CSM agent will invoke that CSM package load command, which will take and populate the correct mini disks or SFS directories on that managed system with this new service level. So once the service level has been installed, I can actually log on to that system and test the new service level content. And I would do that just the same as I would on any other system. So I'd link to alternate mini disks to test the service level as best as I could, however thorough you need to be. Once your testing is done, then you're ready to declare that your service level is stable. And you can do that by simply resending the service level to the managed system, this time with the stable argument. So declaring the service level to be stable means that a lock is now placed on that service level. You can't change it anymore on the principal system. And it declares to the managed system that this service level is ready for a put to prod to actually be executed. So again, the send works exactly the same as it did the first time. And again, CSM package load puts everything in the right place. So at this point, then you would be ready on that managed system to do a put to prod. So that's the last thing to do here. And so this is again done with the serve manager command on the principal system, but this time you're not using serve level. Put to prod is a system level process because it's going to change the system. And so it's the serve manager system command. So the invocation would be serve manager system put to prod 720, and VM01's the target system. So again, this will cause an invocation of FTP communication to that managed system. And essentially the principal system is going to tell the managed system, send CSM agent a put to prod command, have CSM agent fully run through the put to prod process. And then once that full process completes, you get an invocation back to the principal system that that is complete. So then you could actually log on to that system and re-IPL it to put that service fully into production. So that's really the full life cycle of using CSM. You, of course, would have more systems in your inventory that you'd be managing. You'd probably have a mixture of some ESM and non-ESM systems. So it'd be much larger, but you'll be running through this set of commands typically most frequently when you're using CSM. All right, so before we wrap up here, let me just cover some enhancements that are in the works for CSM. So the first, and these are all available for you to peruse on the new function webpage on the IBM VM website. The first of the new function projects is a CSM fix pack. Now, the page on the new function table there lists this as a being targeted for December of 2021. That's only a month away. I don't really think it's going to make that. I think there's still key work going on. So probably it's going to be sometime in 2022 that this will be available. So some enhancements are being made, primarily query enhancements. So the serve level query commands being enhanced to allow you to query a specific component within a service level. So by default right now, if I query a service level within the service level inventory, I get back information about that service level for every component within VM. And so maybe I'm only interested in information, detailed information about the CMS component. So this query would allow me to see the PTFs that are included in this service level for just the CMS component instead of the whole set of information if I do a detailed query. Serve level query is also being enhanced to allow wildcard support for referencing service levels. So Today, I can do a serve level query for a specific service level, or I can do a serve level query for all service levels in the inventory, and nothing in between. So if I have 10 service levels, I might not want to see them all because that's just too much information rolling past. But maybe I've named my service level, so I have a specific set that I could just provide a high level qualifier with an asterisk and just see the content of that set of service levels. So this new wildcard support will allow me to do that. And then there's also a modification to serve level query with regard to local mods. So the output now for local mods will also show the parts that are being affected by that local modification. And then system query is being enhanced to provide detailed information for a pending put to prod. This would be the situation where you had issued a serve level system put to prod, but something went wrong in the put to prod. So the put to prod's pending, it hasn't completed. And typically then you'd have to log on to the managed system to begin to look through logs to figure out what went wrong. This allows a set of those logs to be displayed so you can quickly get some idea of what might have happened to cause put to prod to fail, and fix whatever that was and then redrive the put to prod process. Another new function project is this thing called Key Vault Utility. And so this is really targeted for the second quarter next year. We'll see if it actually makes it there. So this is a replacement for NetRC data. Now, when we were going through this scenario, I didn't bore you with all the times whenever you're dealing with a managed system, there's multiple invocations of an FTP command. And so in the process of that, you're prompted on main CSM to enter CSM work as the user ID and the password for CSM work. And then it does something, it ends that transaction, it starts up something again within the process of what you've selected to do. And now you're prompted again for the user ID and password. And this gets really old when you're doing lots of systems. So a solution to that is to use just the regular old FTP NetRC data file. So I can put, for a target managed system, I can put a user ID CSM work with a password of whatever it is in the NetRC data file. And Serve Manager checks to see if you have a NetRC data file, and if the target managed system is in there, then it doesn't prompt you anymore for user ID and password. It just uses that user ID and password. That's all well and good, except for the NetRC data file is just a regular flat CMS file, so the user ID and password are in the clear. And many customers today are rightfully so being much more security conscious, and they have rules that say we're not going to ever have any user IDs and passwords stored in the clear. So this project is going to implement a CMS-based key store utility that will allow for CSM, but actually FTP can use this too, because FTP is going to be modified to use this as a replacement for NetRC data. So this will have its own set of commands that allow you to define the key vault, to populate it with system user IDs and passwords and so forth, so that when CSM is invoking communication to a managed system, if the key vault's available, it will prompt you once for the key that allows CSM to open the key vault. And then once it's open, it will never prompt you again for user IDs and passwords for managed systems. It will maintain that information in storage, but as soon as you stop or tell it you're going to stop, it will erase all that even from memory. so that the user IDs and passwords won't even be in the memory. But at least they'll never be stored then in the clear on disk or in an SFS directory. All right, so hopefully you have a better idea at this point of CSM. I think I'm actually out of time. So if there were any questions, I'd be happy to try to answer those. Otherwise, thanks very much for listening.
Yeah, thank you, Richard. There is a question which was set for the end. Will the zVM install process have CSM setup built in someday? For instance, the install panel has a checkbox for CSM and asks for DASD to add the file pool, etc., and let the install process handle initial setup and build. Seasoned sysprogs will love this, but newer folks may get lost. Adding more simple to CSM would go a long way, probably.
Yeah, it's actually a good suggestion. I'm not aware that any suggestion like that has been submitted to VM development, so that would be something for a request for enhancement that would certainly probably be well received in the zVM Council. You would probably also want to gear it towards until enhancements are made to CSM to support an SSI environment, you'd want to key this off of the SSI or non-SSI question during install. But yeah, I could see where you could certainly streamline the initialization process if you knew right from the beginning that you were going to be installing a principal system. Because remember, most of the work is done on a principal system. Some is done on a managed system. So I'm not sure how involved you'd want to get.
I'd guess you would want that script to really be more like a wizard, which would probably open the ports on TCP/IP and do some of the basic stuff to set it all up.
Yeah, you'd probably want that included in the IP wizard utility as some options there that would be CSM based, because even today the install process doesn't do anything with TCP/IP. You have to run IP wizard after you've installed your VM system. So
yeah, because there's a lot of VM stuff that requires a lot of manual commands, and having more, shall we say, setup wizards like the IP wizard for TCP/IP to enable new customers to be able to set things up in a more structured way, rather than rely on them to try and make decisions about things they don't really fully understand.
Yep. Yeah, I definitely agree. I think the more we can do to enhance the install process and configuration tools after install to do more.
But the only other thing that I would question was, sorry to interrupt.
Nope, go ahead.
That there was RACF might throw a few spanners in the works here for password management, for example. For if I mean some password change gets past the limit, obviously you're going to have to set the password as never changing. Otherwise, you're going to go around having to change all the passwords every 30, 60 days or something.
Correct.
And that can cause all sorts of problems.
It certainly can, and you'll know about those problems right away when you do any serve manager command that talks to a managed system.
The only other issue that I'm also concerned about with farming this stuff out is what happens if a mini disk blows, and we fill a mini disk on the managed system, and it just stops the install, and that's it. You've got to restart from some point when you've redone the mini disk size.
Yeah, I think most of that is covered in the change of install process now that came in with 6.4, where the default now is to install in SFS. So certainly there's still some mini disks for the nucleus and stuff, but the mini disks that used to fill up are now SFS directories that
for those who use SFS, I tend not to use it.
Yeah.
Call me old-fashioned. When SFS first came out, I implemented it, and I had to back it out because it was full of bugs, and it's
Yep.
made me distrustful of it ever since.
Well, I was just like you up until 6.4, but then when they changed the install process to make that the default, I decided, well, I'm going to give it a try, and it did work quite well, and I haven't had any issues 6.4, 7.1, 7.2. So that's a good solution. But if you have installed all of the components on mini disk, then yes, you do run the possibility of blowing a mini disk, and you would tend to find that out when you did the serve manager send to that target system. And so that command would fail. There'd be enough log data to tell you that the mini disk, some mini disk owned by main 720 blew up. So then, yeah, you'd have to go and you would have to enlarge that mini disk.
We've had a comment that SFS is super cool and flexible. Yeah, I know it is now, but
right.
Okay.
And your scenario is even a bit more insidious, because you see, you'd never know that when you built your service level, because your service level is going to be built entirely in the SFS. So it's just going to be smooth sailing when you build the service level. When you send it and the target has many disks, there's where it might blow up. And so, yeah, that's an issue. And I guess VM development has their head in the sand and is just hoping upon hope that everybody installs in SFS so they don't have to deal with that.
Understood. Okay, thank you, Richard. There's no more questions, so thank you very much for that. That was very interesting. Thank you, everyone, for attending. Goodbye.
Okay, thank you very much for hosting. Take care.
Bye.
Bye.